This is the 8th video presentation for the CASE Ag Power and Technology course. As you view this video, please be sure to make notes of important information. Feel free to pause, repeat, and resume the video whenever necessary. Survey says, Lesson 3.4, Material Management. You have completed Activity 341, Water Velocity, during which you measured the relationship between slope and velocity of water and observed management techniques to control erosion on sloped land. This presentation provides information about land surveys and measurement. Surveying is used to calculate elevation and grade. An elevation is the vertical height above or below a fixed reference point. A difference in elevation on a land formation will affect the structural soundness of buildings, roadways, and earthen structures. The grade of land is determined by calculating the slope between known points of elevation. Changing the grade of land can control the flow of water and erosion of the soil. Surveyors use precise tools and detailed calculations to measure straight lines, distances, elevations, and grade. Surveying requires the work of a team of tradesmen and professionals. A survey team consists of 2 people. Surveyors have 3 major pieces of equipment they use: a tripod, a builder's level, and a leveling rod are used to measure land elevations. Be sure the tripod is securely set in the ground and fairly level before you attach the builder's level. The type of surface the tripod is being set on will determine how it will be securely placed. Attach the surveying instrument securely to a fixed base on a tripod to provide a level plane once the tripod is in place. The builder's level or transit is attached to a tripod and leveled using adjusting screws. Adjust the tripod legs by releasing locking levers to level the head of the tripod. Tighten adjustment screws on the legs so the tripod will not move when attaching the builder's level. A builder's level is an instrument used to determine elevations between 2 specific points. The level has a telescoping device attached to a circular base with adjusting screws. The level is very sensitive and can be broken easily. Handle with care. Use the screws to raise and lower the instrument to make a level line of sight. The line of sight is a horizontal line that does not curve or bend. This line can rotate along a 360-degree horizontal plane and remain level the entire time. Rotate the level 360 degrees after leveling. If the bubble does not move, it is level. Repeat the leveling process if the bubble does move. To use a reading rod, one person needs to hold the rod vertical to the horizontal plane, and another must read the rod by looking through the telescope of the leveling instrument. The numbers are read from the ground up. The closest red number below the crosshair seen in the builder's level telescope is the number of feet. The closest black number below the crosshairs is the number of inches, or tenths of a foot. Carpenters and tradesmen use the architect's rod. The architect's scale shows the number of feet in red with graduated marks. The black numbers represent the number of inches. Small black graduated marks show 1/8 of an inch. The rod reading by the blue arrow is 1 foot, 4 1/8 inches. Surveyors and engineers use the engineer's rod. The number of feet are red in color, and the tenths have graduated marks by a number in black. Smaller graduated marks represent hundredths of a foot. Read the engineer's rod in tenths and hundredths of a foot. The rod reading by the blue arrow is 5.36 feet. As a review, mark or highlight 3 key points in your notes that are important to remember from this presentation. List 2 ideas or concepts that relate to previous knowledge. List any questions you have about this topic. Discuss these questions with your instructor. Keep any notes you have from this presentation organized and available for use throughout the course. Through Activity 3.4.2 Landslide, you will calculate the slope of land between 2 points in order to understand the impact of slope on many agricultural mechanics applications and designs. Your teacher will provide more instructions. Through the activity, you will be calculating distances and slopes using surveying equipment. The next clip provides a demonstration for these calculations. You may want to record the equations and steps in your notes for future reference. The Pythagorean theorem is used to solve for the distance between 2 points that connect the hypotenuse of the triangle and is represented by length C in Figure 1. Side A represents the elevation between the 2 points. You need to find the length of side B of the triangle, which is the run as seen in Figure 1. Then you will be able to calculate the slope using the Pythagorean theorem as follows. The Pythagorean theorem is written as a squared plus b squared equals c squared. Subtract a squared from both sides. Take the square root of both sides of the equation to solve for b. Therefore, if the rise or elevation change between 2 points represented by A is 10 feet, the surface distance or hypotenuse is 85 feet, represented as c. Replace A and C in the equation with these numbers. B squared is equal to 85 squared minus 10 squared. Simplified, the equation is written as B equals the square root of 7,225 minus 100, or 7,125. Therefore, B, or the run, is 84.4 feet. Once you know the rise and the run, you can calculate slope. Divide the rise by the run, or 10 feet divided by 84.4 feet. Multiply by 100 to express as a percentage. In this scenario, you have a slope of 11.8%.